So welcome to our solving quadratic equation. This was our class activity. Ideally, what I would hope is that you are pausing this video, trying these problems on your own, and then checking your answers along with me. So if that is what you are doing, it will make you a better mathematician and prepare you for our upcoming test. So let's take a look at this one. The great thing is this quadratic is already factored for us. Okay, I love it when we have problems like this, and hopefully all of our problems when they're tested will be similar. Here we just take our 8x minus 7 and we're setting both binomials equal to 0. Okay. I just split these in two, set them both equal to 0. And now I'm just going to solve for x. So I know I have plus 7 here. Great, they cancel out. 8x. And then I have my 7. And now to isolate that x, I just need to divide by 8. That cancels out. It leaves me with x equals 7 over 8. So remember, this is one solution, one root to this quadratic. So now I'm just going to solve the other one. Okay. Solving for x, subtract 5 to both sides. My 5's cancel out. Left with 3x on one side, negative 5 on the other. And then I'm dividing both sides by 3. Cancels out. I'm left with x equals negative 5 over 3. And those are both of my solutions to this following factored quadratic. And really what that would look like is when my parabola is graphed, I'm going to have one solution here, or one root at 7/8, another one at 5/3. I don't know exactly what it would look like, but that's where it's crossing. Here at negative 5/3 and here at positive 7/8. Now let's take a look at this next quadratic. Here we're solving for our roots. Remember, our roots are the same thing. Our solutions are zeros. So go ahead, pause this video, try it on your own. I hope you took some time to solve this equation, this quadratic for the roots. And let me see, let's follow along with me. Let's just check my work, see if you got the same thing I did. Hopefully the first thing that you did is you took this equation and you set it equal to 0. Okay, so you can just rewrite this: 2x squared minus 3x minus 5 equals 0. Now, unlike our first problem, this one is not factored, so we are going to have to factor this into two separate binomials. Okay, so here we're going to use our ACB method. So I'll have my A times my C, with my A value being my 2. A times my C equals my B. So I have 2 times negative 5, so I have A times CB is negative 3. So I'm looking for two factors that when multiplied together will give me a negative 10, but when added together will give me a negative 3. So let's see, I can go, well, I know 1 and 10, 2 and 5. That will work right here. Okay, so I know factors of 2 and 5. To make that a negative 10, one of those is going to have to be a negative. Okay, and that's going to be my 5 right here. So now I'm going to factor this. I know a lot of you like to use the box method of factoring, so I'll go ahead and show the box method of factoring here. Okay, because I want two binomials, I'm going to write a 2 by 2 box. In my top left-hand corner, I'm going to put my A, which is my 2x squared. The bottom right, my negative 5. And then I'm going to take my factors and fill in around it. Remember, I have one factor that was negative 5x and the other factor that was 2x. Now, starting with my columns, I'm going to factor out. Okay. So in my first column, 2x squared and 2x, I can factor out a 2x from both of these. Okay. In my second, I have negative 5x and negative 5. Now remember, when possible, if our first is a negative, I want to factor out that negative. So I'm going to factor out a negative 5 from this column. Now looking at my row, I have 2x squared minus 5x. Okay. Here I can only factor out an x. Okay. And then my next row, I have 2x minus 5. Well, I know you may be thinking, oh, I can't factor anything out, but yes, you can. You can always factor out a 1. Okay. So here I have both of my factors. I have a 2x. Let me change that color. It's hard to see on that yellow. I have a 2x minus 5 and an x plus 1. So those are both my binomials. Remember, I'm still equal to 0. And now I'm just going to go ahead and split them and set them individually equal to 0. So here's 2x minus 5 equals 0, x plus 1 equals 0. And now I'm just solving for x. Okay, so I'm adding 5 to both sides. I have 2x equals 5. And then to isolate my x, I need to divide both sides by 2. So one of my solutions is x equals 5/2. So there's one of my roots. The other side, minus 1 to both sides, I have x equals negative 1. And these are both of my solutions to this quadratic. Now the great thing is you can always check this one. Go into your Desmos and graph this entire equation. And when you graph it, you will see this parabola opens up. You are going to have one root here at 5, 2, and the other one where it's crossing the x at negative 1. Now let's take a look at our next quadratic. This is asking us to find the zeros of the function. Remember the zeros? Same thing as the solutions. They can be asked in any way. Zeros, solutions, roots, x-intercepts. So let's take a look at this equation. Okay? Go ahead, pause the video, try this on your own. Hopefully the first thing that you did was you took care of this negative. Okay, we don't want that negative. So take this entire equation and multiply it by negative 1. And when we do so, we now have a positive x squared plus 2x minus 15. Okay, and remember, we're setting that quadratic equal to 0. And we never want an equation in standard form that begins with that negative. Okay. Here it is not factored out, so we are going to have to use our ACB method of factoring. So I have my A times C is my B. Okay, so my A times C is negative 15, and then my B is 2. So I need to find two factors of 15 that when multiplied together give me negative 15, but when added together give me positive 2. And hopefully you chose 5 and negative 3. Okay. Last problem, I went ahead and I used box method of factoring. I think this time I'll go ahead and I'll just split the equation. I do know I have some students that just like to split that equation. So for here, let's see, I'll rewrite. I'll have x squared. And when I split this equation, remember I'm splitting this to x, so I'm going to split this into negative 3x and positive 5x. I just took my two factors here and just split that 2x into those two, minus 15. Okay, so I expanded that equation out, and now I'm going to create two separate binomials from here and factor from there. Okay, from this first binomial, x squared minus 3x, they both have an x in common, so I can factor out an x. That leaves me with x minus 3. My second binomial, 5x minus 15, well, they have a 5 in common, so I can factor that out, and that leaves me with x minus 3, which is perfect because we always know we're on the right track because they both match. And then I have my factors, one of them being here, what I had factored out that matches in x minus 3. My other factor is what I had initially factored from both of those binomials, that x plus 5. So I have two factors, x minus 3, x plus 5. And remember, they're both set equal to 0, and now I'm going to solve for x. So I have x minus 3 equals 0, x plus 5 equals 0. Okay. And now just solve for x. I'm going to add 3 to both sides. So I am left with x equals 3. That is one of my factors. And then here, subtract 5 to both sides. I'm doing this because I want to isolate my x. I have x equals negative 5. And now remember, you can always go and check this by graphing this quadratic, but before you graph it, you need to get rid of that negative. Okay? And what you will see is you will see a parabola that will open up. You'll have one solution here at 3, okay, the other solution here at negative 5. Go ahead, graph this on your own in Desmos and check your work. Let's take a look at this next problem. So here I have x squared equals 5x asking me to solve the quadratic. Well, the first thing is this quadratic is not equal to 0, so I need to set it equal to 0. So I need to move this 5x to the other side of that equal sign. Okay? How I do that is I just subtract 5x to both sides. Okay, so now I'm left with x squared minus 5x equals 0. Perfect. Now I can just factor this. Let me rewrite this up here. X squared minus 5x equals 0. Now looking at that x squared minus 5x, what do they have in common? Well, hopefully you already know that you can factor out an x from both of these. Okay, so when I factor out the x, I'm left with x minus 5. And remember, I factored out that x. Still both set to 0. And now just split these into two separate. So I have x equals 0. Nothing to solve there. I know that that's one of my solutions. And then x minus 5 equal to 0. And now I'm just solving for x. So here I have x equals 5. And there you go. There are both of my solutions to my quadratic. My x equals 5 and x equals 0. And once again, I can always check that by going into my Desmos and plugging in x squared minus 5x. And you're going to see a parabola that crosses that x at 0 and 5. On this quadratic, our first step is we're going to have to factor this. Okay, we're using our ACB method. Okay, 2 factors AC, which is 24, but when added together give me negative 10. So we can go through all the factors of 24. We know 1 and 24, 2 and 12. Okay, that made 3 and 8, right? 4 and 6. Let's see, and now we're going to start repeating. So we need to find two factors that when multiplied together will give me a positive 24, but when added together will give me a negative 10. So take a look at the factors. Which one are you choosing? Okay. Hopefully you chose the 6 and 4. Okay. Because remember, if I set both of these as negatives, when I multiply them together, negative times a negative is a positive. But when I add them, a negative plus a negative is a negative. Okay? This one here, I'll just go back to solve by box method. So since I want two binomials, I'm going to draw a 2 by 2 box. Okay? In my upper left-hand corner, I'll put my x squared. In my lower right-hand corner, my 24. And then I'm going to put my two factors around. So here I can just put my negative 4x. On this side, my negative 6x. Okay? And now I'm just going to start factoring out. Okay? So looking at my first column, I have x squared negative 6x. Well, they both have an x in common. My next column, I have negative 4x and 24. Well, I'm going to factor out a negative 4. Remember, when at all possible, factor out that negative if it's in the first term. Now looking at my rows, x squared minus 4x, I have an x in common. And then my next row, negative 6x and a positive 24. Well, I'm going to factor out that negative 6. Okay? And now I have both of my factors, my x minus 4, x minus 6. So I'm going to write those as two binomials, x minus 4, x minus 6. Okay, remember they're still equal to 0. And now I'm going to separate them and solve them as individual binomials. So here I have x minus 4 equals 0, right? And then on my next, I have x minus 6 equals 0. And now I'm solving for x. I'm adding 4 to both sides. So I have x equals 4. And here I'm adding 6 to both sides. X equals 6. And my quadratic has two solutions. And if you were to go into Desmos, you can graph this entire thing, x squared minus 10x plus 24, and you are going to see a parabola opens up, okay, that has two roots. Oop, that was a bad drawing there. Let me go ahead and erase that. There we go. It's going to have two roots that cross that x-axis, okay, at 4 and 6. So now let's take a look at this next question. So here we're asked to find the values of x as it relates to this rectangle. So let's take a look. Remember, area of a rectangle, I have an area of 234. Okay, area of a rectangle is just my length times width. So here I have x, right, times 2x minus 8 equals 234 yards. So let's just go ahead and solve for that x. Okay, I'm just going to distribute. So x times 2x is 2x squared. X times negative 8 is negative 8x equals 234. Okay. And do you see what I see? It's looking like a quadratic. It is a quadratic. So we can solve this by solving our quadratic. The first thing that we need to do though is make sure that this quadratic is set equal to 0. So I need to move that 234 to the left side by subtracting 234 from both sides. So I'll be left with 2x squared minus 8x minus 234 equals 0. Okay? And now I need to factor this. So let me go ahead and rewrite this equation at the top. So here I have my quadratic 2x squared minus 8x minus 234, okay, equals 0. So I need to factor. Before I do anything, I'm going to check and see if there's anything I can immediately factor out of that equation. And I can, they're all even numbers, so I'm going to factor out a 2 out of this equation. So that would leave me with a quadratic of x squared minus 4x minus 117. Okay. And now I'm just going to use my ACB method to factor. Okay, my A times C equals my B. So I need something that when multiplied together will give me 117, but when added together will give me a -4. Now this is one that you may have to use Desmos in. Remember, go into Desmos and put in y equals that -117 over x. Okay, you're then going to go up to that right hand and choose that gear button. I know for mine, I'm drawing it looks like a flower, but it's a gear button. Okay, create that table, and then you should be able to find all of the factors of that 117. So when you did that, okay, you should have come up with 9 and 13. Okay, 2 factors. Now because my 4 needs to be negative, remember my 4 here is a -4, I'm going to make that 13 that negative. Okay. And now I'm just going to go ahead and I'll factor using box method again. That seems to be a class favorite. So I have my x squared, my -117, and then I'll just put my -13x here, my +9x, and now I'm going to factor out. Okay, so from my x squared to 9x, it has x in common. My -13x and -117, well, I know it has a 13 in common. And now I'm looking at my rows. X squared minus 13x has an x in common, and 9x minus 117 has a 9 in common. So I have 2 factors. I have x minus 13 and an x plus 9. And now that I have both of these binomials, I just set those equal to 0. I'm going to separate them out, and I'm going to solve each for x. So here I'll have x equals 13, x equals -9. And these right here are the 2 factors of my equation. Okay. You can always check that. Go into Desmos and just plug in this entire thing, 2x squared minus 8x minus 234, and you're going to see that this parabola will cross my x-axis at +13 and -9. This problem is asking us which statement about the following function is true. So we have x squared minus 576. So we can still use ACB method if you don't see right off the bat. Okay, so let's use ACB method. So we have A times C, which is our -576, equals our B. What's our B? You're right, it's 0. Okay. So go ahead and go into your Desmos calculator and plug in that y equals minus 576 over x, and pull up all of the factors of 576. Now remember, we're looking for two factors that when added together are going to give us 0, but when multiplied together will give us 576. Hopefully by now you saw 24 times 24, which means 576 is a perfect square. Okay? This quadratic is one of our special cases where it is a perfect square. So remember from our previous lessons of special cases, with the perfect square, we can break that up. One is going to be a plus, one is going to be a minus. Okay, we'll have our x plus x. And then you found 24 times 24, so here we have a positive 24, negative 24. Okay? Those are both of our factors. And now we just set these equal to 0 to find our solutions to our quadratic. So I'm going to have x plus 24 equals 0, and x minus 24 equals 0. And now I'm going to solve. So when I do, I'll have one solution at negative 24, one solution at positive 24. And let's look at my answer choices. Let's see, the first A is the only 0, 288 can be found when 0 equals x minus 288 squared. Well, we know that one's not it. The second is the only 0, meaning 1. Well, no, we have two zeros, one at negative 24 and one at positive 24, so we know that's not it. Okay, C tells me I have two zeros, which I do, negative 24 and 24, but this tells me at negative 288 and positive 288. That's not it. And then let's look at D. But the zeros, negative 24 and 24 can be found. There we go. That's correct, and D is my answer. So we already did this problem here on the left-hand side, the x squared minus 10x plus 24. Once again, never hurts to practice some more, so go ahead and you can practice that. But let's take a look at this x squared plus x equals 12, and let's go ahead and solve the quadratic. Well, the first is we need to make sure that our quadratic is set equal to 0. It's not, so we need to move that 12 from this side of the equation to the other. We do that by subtracting 12 from both sides. So it leaves me with x squared plus x minus 12 equals 0. And now I'm going to factor. Okay, I need to find two factors that when multiplied together will give me negative 12. But when added together will give me a positive 1. So hopefully you identified 4 and 3. Okay, because my 12 is negative when multiplied, one of those factors, one of those has to be a negative, but I have a positive 1. So I know my 4 is going to be positive, my 3 is going to be negative. Okay. I know the past couple times I've used box method, so this time we will go ahead and separate. So here I have x squared, and remember my middle, I am just simply going to split this into both of my factors. Okay, told me that I factored to a negative 3x and a positive 4x. Okay, all I did was just split that x up into two factors, and then I have minus 12. Okay. And now I'm just going to factor out from there. So x squared minus 3x, they only have that x in common. So when I factor out an x, I'm left with x minus 3. 4x minus 12, they have a 4 in common. And when I factor that out, I have x minus 3, which is exactly what I wanted. I always want to make sure that these two that left that I factored out in parentheses match. So we know what I've highlighted here is one of my factors. I have x minus 3. Another binomial factor is what I had initially pulled out. So here I pulled out this x, I pulled out the 4. So that is another binomial. Okay, I have my x plus 4. And now remember, both of these are set equal to 0, and I'll go ahead and solve that. So I have x minus 3 equals 0 and x plus 4 equals 0. And then I'll solve. That will be x equals 3 because I'm adding 3 to both sides. Here it would be x equals negative 4. Okay? And that's the solution to this quadratic. Okay? You can always check it by just going into your Desmos, plugging in this equation here.